Okay, ladies and gentlemen, welcome to this Ed puzzle. This is called Lesson 1.3, Exploring Earth's Plates. You're going to find out what that means in just a second. But before we get going with this Ed puzzle, let's make sure we have everything we need to be successful. And here are those items. Please make sure you have out your science notebook. Turn in your science notebook to the next blank page after the notes that we previously took. Make sure you have a pen or pencil, obviously. And of course, if you are a rock star, that means you're listening to me through your headphones right now that you have on, and you're all ready to go. Please put everything else on the floor so you're not distracted by anything else. And yeah, if you need to hit pause and get these things out, go ahead and hit pause. And then when you're ready to go, press play and we will continue. Okay, let's go. Some review questions are going to pop up on your screen here in Edpuzzle, and go ahead and answer these in Edpuzzle and show Mr. Larson what you remember from our last couple classes. First question, true or false? Scientists wanting to know more about the Earth can use a hollow drill to remove a cylinder of rock or ice called a core sample. Go ahead and answer that question now. Okay, now that you answered that, hopefully you knew the answer was true. A core sample is exactly that. It's a cylinder of rock or ice that we drill out of the ground, sometimes thousands of feet deep, and then we learn about Earth through these core samples. Okay, let's do our next review question. Oh, by the way, core samples you see here on the screen, they get older the deeper you go, right? They get older. So if you dig down and remove a core sample, you're going to get older and older and older the further down you go. So if you want to study the Earth 100,000 years ago or a million years ago, you have to go down to that depth, dig up that core sample, and then the deeper you go, the older information that you can get. Kind of cool. Next review question. Answer this question when it pops up. True or false? Earth's outer layer is called the mantle. Answer that question now. Okay, hopefully you knew that one. That was easy. The answer here is false. The Earth's outer core is called the crust. It's the layer that we live on. It's kind of like the shell of an egg made of solid, hard rock. It's anywhere from 30 to 50 miles thick. And without this surface, basically our planet would just be a giant ball of lava. So it's really important that we have this crust, this surface that we live on. It's kind of like the shell of an egg. Protecting us from the crazy heat of the mantle down below. Here's our next review question. True or false? Scientists can use information learned from core samples to create helpful diagrams we call cross segments. Answer that question now. And this was kind of a tricky one. Kind of scummy, Mr. Larson. This one was a little tricky. This one is actually false. They're not called cross segments. What are they called? They're called cross sections. Cross sections. I know. That was kind of a dirty trick. Cross section is what we see here. A picture of a tooth where you can see the inside structure of something, kind of like it was sliced open with a knife. These are called cross section diagrams. And yeah. Hopefully you knew that. Next review question, true or false? If you removed all the living soil, clay, living things, and the water from on top of Earth's crust, you'd basically end up with a giant ball of rock. Answer that question now. Yeah, I'm sure you got this. The answer is true. Very good, very good. This is kind of a representation of what the Earth would look like without anything on the surface. If we removed all the rock, all the soil, all the houses, all the trees, all the water, basically Earth would just look like a lifeless ball of rock. Not too different than when we look at our moon, right? Yeah. Okay, let's keep going. Today we're going to explore Earth's crust. Earth's crust. A little bit later, you're going to learn who that guy is that pops up on your screen. That's Alfred Wegener. Everyone say, hey, Alfred. Yo. Okay. Let's start by watching a quick video. This shows a 3D computer model of the surface of the Earth, and it's going to show you the Earth's crust. And after watching, you're going to have to answer these two questions. A, what did you notice during the video? B, What's a question that you have about what you saw? So while you watch, think of something you notice and a question that you have from what you see. Let's watch that video now.
Below the soil and water we see on the surface, the Earth's outer layer is made up of hard, solid rock. This computer model removes the water from the ocean basins so we can get a better look at the hard, solid rock of Earth's outer layer. The model is changing to exaggerate the height of the landforms on Earth's outer layer so we can better see them. This cross-section of the Earth's outer layer helps us see the different landforms on the Earth's rocky surface. It wasn't until scientists mapped the ocean floor in the 1950s that they had evidence that there were landforms there.
Okay, very good. Please answer this Edpuzzle question when it pops up. Answer these questions by writing a complete sentence for each one. A, what did you notice during the video? Just something quick. And B, what is a question you had about what you saw? Answer that Edpuzzle question now. Okay, let's continue. Please open your science notebook to the next blank page and give it this title, 1.3, Exploring Earth's Plates. And if you want to be a little extra, add today's date on there too. Press pause and write down that title, and then hit play when you're ready to continue. Okay, now that you've written down that title, let's get going. So, first point, just like an eggshell can have cracks in it, the Earth's hard rocky crust is also made of a dozen or so separate pieces. Look at this picture. This egg contains probably 50 or 60 little itty bitty pieces of eggshell. The Earth's crust is cracked just like this, except it's not cracked into as many pieces. The Earth's crust is not one solid ball of rock like an eggshell that's unbroken. It's actually more like this picture. It's cracked into a bunch of pieces, just like the cracked shell of an egg. Let's write this down in our notes, press pause, and then hit play when you're ready to continue. Okay, now that you wrote down those notes, let's continue. Watch this video.
These plates that sit closer to the surface are in fact huge. Some of them covering entire continents. And they're made up of major plates and minor plates. Check out this map. Here, you can see all the plates on Earth. As you can see, there are 7 major plates and 10 minor ones. The first thing you may notice is that the major plates are kind of aligned with the continents. That's not a coincidence. The continents on Earth were actually formed due to the movement of these plates over millions and millions of years. Think of the Earth as a giant jigsaw puzzle, made up of pieces that are basically parts of these major plates.
Okay. So, you learned something in that video. We call these pieces of the cracked crust of the Earth tectonic plates. Tectonic plates. And here's the map that you saw in the video. Look at all these different colored pieces. Each different colored piece, like the purple one, the yellow one, the brown one, each of them is a single tectonic plate. It's like one piece of the Earth's cracked eggshell. Look at this piece right here, the brown piece where my cursor is moving. This is called the North American tectonic plate because it contains the entire continent of North America, Canada, the United States, and Mexico. But it also extends all the way out here to the Atlantic Ocean, contains all of Greenland, half of Iceland, that's this little country right here, all of Alaska, and even some of Russia. So this is a giant piece of the Earth's cracked eggshell that we call a tectonic plate. Look at this yellow tectonic plate right here. It doesn't look like it on this map, but this is actually the largest tectonic plate on Earth called the Pacific Plate. It doesn't have any major continents on top of it. It's basically the entire Pacific Ocean, probably 30% of the Earth's crust. So each of these colors has a different name, and each one is its own tectonic plate. Let's write this down in our notes. Press pause and then hit play when you're ready to continue. Okay, now that you wrote that down, this says pieces of the Earth's crust float on top of the mantle are called tectonic plates. Remember, there is a layer below the Earth's crust, and that's the mantle. So these pieces of Earth's cracked eggshell are actually sitting on top of the mantle. Picture it like this. I love this little image because, first of all, it shows the Earth as a round sphere instead of a flat map. Second of all, what's that red layer under there? Yeah, that's the next layer down. That's the mantle. That's the hot liquid rock, the magma or the lava. That's the mantle underneath it. Pretty cool. Here's a little GIF. It shows those plates splitting apart, and underneath it, we have that glowing hot lava, the mantle layer below the crust. Kind of like removing the shell from a hard-boiled egg. Let's sketch the Earth's cracked crust in our notes. So hit pause and copy down this drawing and label it just like you see it on your screen. Hit pause and then hit play when you're ready to continue. Okay, now that you sketched that and labeled it in your notes, let's continue. Please answer this Edpuzzle question. What do the Earth's tectonic plates sit on top of? Answer that question now. Okay, now that you answered it, the answer hopefully was easy. The Earth's tectonic plates sit on top of the mantle, which is hot liquid magma or lava. Very good. Okay. Guess what, everybody? I have a secret. Earth's tectonic plates don't just sit still. My God, they move. They're actually moving around. As we speak, as you're sitting here in your chair, the Earth's crust is moving below your feet. It's true. They move. Mind blown, ladies and gentlemen. Mind blown. Is your jaw dropping to the floor? Wow. Exciting stuff. The tectonic plates are moving. This is a big deal, guys. All joking aside, this means something. It means that the surface of our world is constantly changing, even though we don't realize it. Earth's surface is always changing right under our feet. And here's this same tectonic map showing all the plates, all the tectonic plates. But see those arrows? Those arrows show the direction that these plates are moving. Look at the big green one in the middle. That's the African plate. That entire tectonic plate is moving to the east and a little bit to the north. Look at the orange plate. That's North America. North America is moving mostly to the west. So each of these plates is moving in a slightly different direction. Kind of like taking a puzzle and trying to move around the individual pieces of the puzzle. Can you imagine what's going to happen where these puzzle pieces meet? Even though you can't tell, the plates are actually moving right now underneath your feet. You can't tell because they're moving so slowly, guys. The plates are moving at the speed that your fingernails grow. And this changes the surface of the Earth, but it means that these changes take an incredibly long time. This is not something you could notice in a lifetime or even 10 lifetimes. This is something that happens over thousands and millions of years. Here's what a tectonic plate map of the history of the Earth would look like. Pretty soon, you should see some recognizable shapes. Here they come. And they split apart now, just at the end of the GIF. Each one of these blobs is a different landform, but each one of these kind of square pieces outlined by the gray lines is a different tectonic plate. And this is how scientists have calculated those plates have moved over millions of years. You're looking at a few 100 million years of Earth's surface changing. And if we look at just the plates, just the land masses, this is what the movement of the plates would look like. This is a few 100 million years of Earth's surface sped up in fast forward. Kind of crazy. We can't even tell this is happening. Okay, press pause, write this in your notes, and then hit play when you're ready to continue. Okay, now that you wrote that down, let's continue. Press pause and write these notes down in your notebook, and then hit play when you're ready to continue. Okay, now that you wrote those down, here's an Edpuzzle question for you. Write 2 full sentences explaining to a 3rd grader, they're kind of dumb, why the surface of the Earth is always changing. Answer that Edpuzzle question now. Okay, now that you answered that Edpuzzle question, here's my answer. Maybe yours was kind of like mine. The surface of the Earth always changes because the tectonic plates are moving. This causes the continents to change their location over time. Okay, time for our next concept. Now that you know that the Earth's surface is made of these tectonic plates and that they're moving around, here's a little bit more information. Earth's crust doesn't have the same thickness everywhere on the Earth. In some places, it's thicker, and in other places, it's thinner. Here's a cross-section of Earth's crust. You see over here on the left, we have a thicker piece of the Earth's plate, and over here on the right, we have a thinner tectonic plate. Some are thicker, some are thinner. Answer this Edpuzzle question now. Okay, now that you answered that Edpuzzle question, here's the answer. Super easy, hopefully. Some of the crust is thicker and some of the crust is thinner. Very good. So there's 2 different thicknesses of crust. And here's why this matters. The thicker crust that sticks out above the ocean water is called continental crust. You've heard that word before, continental. It means the continents, like North America that you're sitting on right now, and Africa, are part of these thicker pieces of crust. See the red arrow in the picture? It's pointing to a continent. What is a continent? It's just a piece of the Earth's tectonic plate that's thicker, so it sticks out above the ocean water. See how this works? This is why we have continents on planet Earth. Let's go to another one. The thinner crust, see the red arrows? See what they're pointing to? They're also pointing to the Earth's crust, but that Earth's crust under the oceans is thinner, and we call it oceanic crust. Oceanic. That's kind of a hard word to say. Say that to yourself in your brain. Oceanic. Oceanic. Yeah. So that's why we have crust under the oceans. It's thinner than the continental crust that sticks out above the ocean water. Here's another little diagram. On the left, we have a thicker plate. It's a continental plate. It sticks out above the ocean water. And on the right, we have an oceanic plate, a piece of the oceanic crust. It's made of thinner crust, and it's covered up by water. So we can't see it when we look at a globe. Very good. Here's a cross-section diagram. It's like you took the Earth's surface and sliced it in half. The continents are thicker crust. And the underneath the ocean is oceanic crust, which is thinner crust. See how this works? Very good. Press pause and write this in your notebook, and then hit play when you're ready to continue. Okay, now that you wrote that down, check out this map. This is a standard map of the surface of the Earth. And see these areas right here? We call these continents. But now you know that these continents are actually just thicker slabs of the Earth's tectonic plates, the Earth's crust. And the reason we see them sticking out above the ocean is because they're thicker. And if we look at these parts of the ocean, it's ocean water, yeah, but underneath there is just thinner pieces of the Earth's tectonic plates. These thinner pieces don't stick out above the surface of the ocean. Instead, they're hidden under the water. Anywhere you see oceans on planet Earth, there's crust under there, there's rock under there. It's just thinner, so it's covered by water. Kind of cool, huh? Okay, answer this Edpuzzle question now. Okay, now that you answered that Edpuzzle question, here's Mr. Larson's answer to why we have continents on Earth. The Earth has continents because continental crust is thick enough to stick out above the surface of the ocean, making land masses that we call continents. If we didn't have any thicker crust on Earth, the entire surface of our planet would be covered in ocean water because there'd be no land sticking out above the water. Kind of amazing, right? Kind of crazy to think about an entire planet that could be covered in nothing but water. Okay, time to draw. Please draw this cross-section drawing of Earth's crust in your notes. Press pause, draw this, sketch it, and label it just like I have it. It's going to be important tomorrow. Hint, hint, hint. Press play when you're ready to continue. Okay, now that you drew and labeled that in your notes, let's continue to some important information. What do we see here? Well, we have this curve where my cursor is. This is the crust of the Earth, the eggshell that we live on. And some parts of this eggshell are a little bit thicker, and we call those continents. They stick out above the ocean water here. And then what do you think this scalloped line represents? Yeah, that represents the ocean water. So where my cursor is now, that's the ocean. And what does the ocean sit on top of? Thinner Earth's crust, thinner tectonic plates. And we call these oceanic crust, oceanic plates. And then, of course, underneath all of this action is a giant thick layer of lava or magma that we call the mantle. So this cross-section diagram is super simplified, ladies and gentlemen. Don't think this is super accurate, right? But this is a simplified version of what the Earth's structure looks like if you were to slice it in half. Okay, big announcement, ladies and gentlemen, big announcement. Your next science class is going to be an important one. You have a quiz, and it's over these concepts. Maybe take a screenshot of this screen right now so you know which parts of your notes you need to study. You need to study Earth's layers, all 4 layers and what they're made of, core samples, what that means, cross sections, and maybe some examples of cross sections, and then everything from today's Ed Puzzle about basic tectonic plates, continental plates versus oceanic plates, why the Earth's tectonic plates are moving around a little bit, what are they sitting on top of, what layer is underneath them. So take a screenshot of this, and one last step before we're done. Please take photos of all of your notes in your notebook with your iPad before you leave. Everything from layers of the Earth through the notes we took today. So today, all the way back to layers of the Earth, and make sure you study those for your quiz next class. Ladies and gentlemen, I'm very proud of you. You made it through this lesson. Good job. Give yourself a round of applause, a pat on the back, and have a great day. Thank you.